Welcome back. In today's video, we are going to look at a nice concept, and one of the nice concepts that we are going to focus on is what we call the multi-threading. So before we begin, we have to understand what is a thread. So we have to understand what a thread is. In programming, we have what we use. We have multiple programming languages, and multiple programming languages use this concept, the thread concept. We have what we call the single-threaded programming languages. Programming languages. Programming languages. We have the multiple. Can duplicate this. Multi-threaded programming languages. So what is a thread? So behind the scenes, when you come down here, when you are building your software has what we call the background tasks. By this I mean it is consuming your RAM and your CPU. By default, in Java, we have what we call the heap memory. So by default, when you are building your software, creating variables, running groups behind, we are using these two. We are using the RAM and the CPU, and your computer has what we call the cores. So the cores help you to divide multiple tasks to be executed on your computer. So a thread is a smallest unit of execution within a process. So let me say you're adding two numbers. Can put here some space. Say let me say you're adding. Let me say you're adding two numbers. You're having 1 plus 2, something like this. Simple examples. And down here you're having 3 times 4, something like this. So what does a thread mean? So a process taking place within an execution is what we refer to as a thread. So in this case, what will Java do? Java will first come here, first execute 1 plus 2, print out the result, execute, and it will do it it will be in a synchronous way of executing things. First executing 1 plus 2, then executing 3 times 4. So if you're having multiple processes taking place, it will execute in a synchronous way. So by default, Java is running things in a synchronous way. So what if you have multiple tasks that are taking place and you want them to run in the same time? What will you do? So there we introduce something called the multi-threading processes. So as I previously explained, in single-threaded programming languages, we have a programming language called the Node.js. We have JavaScript. So we have multiple languages that are single-threaded. They execute things in a synchronous way. So in this part, the multiple threading, we have what we call we have Java. So Java is a multi-threaded programming language whereby it executes processes. It can execute processes in a multi-threading way. So we have Java, we have the C languages, among others. So today we're going to focus on multi-threading. So by default, I can remove this. So by default, Java is running in a synchronous way, meaning Java is using a threaded way of doing things. So let me give you an example. So I can print here, I can print something. So let me give you, like, I'm having two numbers. I'm having num1 got like 20. So I'm having even num2, which is like 30. So in this case, down here, I'm trying to print out num1 times num2 times num2. So something like this. So I can print out this somewhere. I can use this right terminal in this case. So I can print out this. I can first remove this Java, um, this Java the main Java. So I can compile and run this. So what is happening behind the scenes? So Java, what Java does is that you're having this main method. So what will Java do? It will first execute the main method. So in this case, sorry, this is a class. I'm meaning this one, the main method. So it will execute this main method and it will use a synchronous way of doing things. By synchronous, I'm meaning it will execute a line by line in that case. So what will Java do is that we're having this method, it will first execute the main method. So it will look inside the main method. What are we having in the main method? So it will come line by line executing one by one. So in this case, in the lines that it is going to execute, we're having this system dot print out. So in this case, we are expecting our result back. So when I run and compile, you can see that I'm getting the 600 as an answer. So that's what we refer to as a single threaded way of executing things. In this case, we are executing one by one, and this is and a thread, as I previously explained, is simply a smallest unit of executing within a process. So this is also a small, this line here itself is a process, this line here is a process. So what if I want to execute multiple tasks at the same time, at one time? So what will I do? I can first come here. I want to execute multiple tasks. So having, let me say you're having, I can give you an example of a restaurant. You don't want one person to do all the things. You want multiple processes in your restaurant to take place. Let me say I'm using a system. I'm in a system, and in the system that I'm in, I'm having a registration. I'm having a login. All processes taking place. So in this case, we are going to achieve this right now. So in this case, I'll come here, I'll create a class. So I can use, how do you see, I use examples like loops. So a loop can execute multiple times. Yeah, let me use loops. So let me create classes. Class, first class is class A. So it is having a for loop inside. Is having a for loop. So in this case, which is int int. This is our variable is equal to 1. So in this case, we're having what we call our, it should be less than 10, something like this. So which is equal to I, which is must be equal to it should start or it should stop at 0. So something like this. So in this case, we are saying system.out. We are printing out, let me say, each and every time that it loops, it should print out high. So I can put this into a method. So I can say my is called, I say public show, which is a void data type. I don't want to return anything. So this is our show method. Inside, we're having our for loop, which is this. So I can use this. In this case, this will be like B. I can leave the show. So instead of printing out hi, I can print out hello. So we're having these two classes. So I can create their objects down here. I can say, object one or class, which is A, is object one. Say object one is equal to the new instance of the object, which is A. And the same thing I'll do down here. So this will be B and this will be instance. So I can call the show methods that I'm having here. So in the first instance, having A dot show something like this. So I want to execute this. Oh, this is object. Make this object 2. So I can say object, in this case, object dot show, then object 2, in this case, object 2 dot show. So I can have these two methods or these two classes, and let me try to compile this. I expect this to work as intended. Oh, we're having a loop. We're having a loop that won't stop. Oh, this is not okay. So let me first check my logic that I use. So we are saying this should loop from it should be less or equal to let me see where is the mistake in my loop. I think the mistake is here. Oh, what am I doing again? So this is increment. Yeah, this has to increment not equal to 0. So I was trying to repeat the same process here, the initialization process, meaning it has to go into an infinite loop. So something like this, when I compile and run, you see that I'm printing out hi 10 times and hello 10 times. So something like this. So what if I want to print out the hi and the hello in a parallel way? So I'm printing out hi and hello at the same time, not printing out hi, because in this case it is running in a single threaded way of doing things in a synchronous way. So what if I want to achieve multi-threading in this case? So behind the scenes, what Java does is that here, when you're using or when you're building actual softwares, you use something like frameworks. So frameworks behind the scenes help you achieve this multiple threading, whereby you don't have to write the things we are going to do. It does it automatically, but you have to understand the processes behind the multi-threading. So that's why I introduced such a nice topic to understand what is happening behind the scenes. So in normal of doing things, or when you're using a framework like Spring Boot, it will use multi-threading behind the scenes. But Java here, we want to understand what happens when we talk about multi-threading. So in this case, we are executing the show hi 10 times and the hello 10 times. We are executing in a synchronous way of doing things. So what if I want to execute in a parallel way of doing things? Or what if I want to achieve what we call the multi-threading? So in this case, it's very easy. You come here, you extend what we call thread. In this case, thread. So automatically after extending the thread, this is capital, sorry, this is capital. So we shall extend the thread. In this case, this shall be extend thread. So in this case, what you are trying to tell Java is that this is going to run in a this is going to be in a multi process in that case. So this class here is going to be in a multi process. So I'll do the same thing here. Thread, I'll extends thread. Yeah, something like this. So let me compile this and we see if there is any change behind the scenes. So compile and run. We are still getting hi and hello, which I don't want. I want to receive hi and hello in a parallel way. So what will I do in this case? What I can do is that Java gives you access to a, a method called start. So can I use the start method? Okay, let me try that. So I'm going to explain this in a minute. So let me use the start method. Even down here, I'll use the start method. Start method. So behind the scenes, when you enter into this class, or before we enter into this class, you are seeing that here on this object, after using the start, you are expecting this to also be in using start, and it is not showing any errors, or it is not showing that something wrong is happening, meaning there is something happening behind the scenes. So let us go inside this start and we understand what the start is. So a start is a thread class, is inside a thread class. So a start is helping us to execute in a synchronous way of doing things. But you can see that a start is having what we call the start it is having what we call the start method, meaning in this case the start method is available for us to use. So in this case, what we can do is that the start helps us to give us it can help us to execute things in a multi-threaded way of doing things. So instead of using a start word here, I'll use what we call the run. Yeah, in this case, start works with what we call the run method. So if you are to use the start in your classes, you have to automatically use what we call the run. Remember that. If you don't use the run, it won't work. Simply because the start, it will look at in this object here, the one that you're having, is it having a method called run? So automatically, after finding the run method, to execute that first. So something like that. So can we compile and we see what's happening? Compile and we see. Oh, yeah, we have successfully achieved what we call the multi-threaded way of execution. You can see that hi is being executed first, and we're having two hellos, then hi, then hellos, hi, then hellos. So we have successfully achieved what we call the multi-threaded way of doing things, whereby you having multiple tasks being executed in the same time. So there is one nice concept that I want to explain is what we call behind the scenes. Behind the scene, what Java does is that we have what we call the scheduler. So what does the scheduler does? So in your CPU or in your computer, we have in what we call the cores. So the cores help us to execute multiple tasks. So if many like on Windows, you're having one core, you're having two cores, three cores, four cores. So all your tasks are divided between those cores. So that's the same thing that is happening up here. So what does the scheduler does? The scheduler will divide all your tasks to your cores. Let me say you're having 500 tasks being executed. So what the scheduler does, it will divide those tasks to your cores. That's what the scheduler does. That's why you're having hi and you're having two hellos, then hi, then four hellos, then hi again, then the scheduler is the one doing this. It is arranging your tasks based on your cores that you're having. So you have, if you're having two cores, if you're having four cores, the scheduler behind the scenes, it will do that for you. So that's simply uh, today's lesson. So what if I want to have hi on this line, then hello in this line? So what will happen? That will be an interesting thing. So we shall look at that in the coming video. Thank you.